Okay, so here we'll be looking at how do we find remainders when a factorial number is divided by a large number. So we'll be looking at two distinct examples, but the first thing is that whenever we find a situation when we are dividing a factorial with a large number, it in 99% of the cases it is solved using the Wilson's theorem. So we already have looked at Wilson's theorem in the previous lecture. So Wilson's theorem basically states that the remainder when p minus 1 factorial is divided by p and p is a prime number, then the remainder is equal to minus 1, which is equal to p plus 1. So this is the Wilson's theorem. Now in the first question we have to find the remainder when 110 factorial is divided by 107 square. So we can first, we already know there is already a 107 here. So we can write it as 1010. So 110 into 109 into 108 into 107 into 106 factorial whole divided by 107 square. Now whenever we bring out one of the 107 outside from both the numerator and denominator, we can write 107 as it is. So now we can cancel out one of the 107 from both numerator and denominator. So I have removed 107 from here and one of the 107 is removed from here. Now we know that remainder when 106 factorial is divided by 107, we already know this is minus 1 by Wilson's theorem. So we can just separate these four remainders out. So we'll have 107. Now remainder when 110 is divided by 107 is 3. Remainder when 109 is divided by 107 is 2. Similarly, remainder when 108 is divided by 107 is 1. And 106 factorial divided by 107 is minus 1. So therefore we get minus 6 into 107. So the remainder would be nothing but minus 6 into 107 plus 107 square, which is 10807. So this is the required remainder in this case. Okay. So now the second problem is find the remainder when 17 factorial is divided by 289. So we have to find the remainder when 17 factorial is divided by 289. Now from Wilson's theorem we know that 16 factorial, so 16 factorial plus 1 is a multiple of 17. So it can be written as 17k. Now 17 is prime, therefore p minus 1 whole factorial plus 1 is a multiple of 17, which is the value p here. So therefore we can write 16 factorial as equal to some 17 k1. So I am just writing, so basically, okay, I'll show one more step here. 1 plus 16 factorial is 17 k1 plus 17. So basically I have just put k as equal to k1 plus 1. k1 is some other integer. So 16 factorial is 17 k1 plus 16. This k1 is some integer here. Now if we multiply both the sides by 17, we will get 17 factorial equal to 17 square k1 plus 16 into 17. Now we know that 289 is nothing but 17 square, and if we divide 17 factorial by 17 square, so remainder when 17 factorial is divided by 17 square is equivalent to saying remainder when 17 square k1 plus 16 into 17 is divided by 17 square. Now 17 square and 17 square, this will be cancelled out. So we will be left with the remainder of 16 into 17, which is equal to 272. So this is the required remainder in this case. So basically we just have to keep in mind that whenever we face a situation where we are dividing factorials by large numbers, in 99% of the cases we use the Wilson's theorem to find the remainder.